Hey everyone, thanks for joining us for today's webinar, Serverless Jenkins with Jenkins X. Before we get started, just a couple of things to let everyone know. We are recording, so for any reason you need to leave at some point, or you have a colleague who isn't able to join, there will be a recording available later on. All of you will get an email with that link. On top of that, you can ask questions as we're going, and we'll have time at the end. So please, as soon as you think of a question, even if you think maybe we'll answer it later or maybe we won't have time for it, please put it right into that question panel, right on that control panel you have, and we'll get to it at the end. So I don't want to take up too much more time. So I'd like to introduce our two speakers today, James Strachan and James Rawlings. And let's jump right into it. James Strachan, would you like to start us off?
Thanks, Max. Hello, everybody. Let's talk serverless Jenkins with Jenkins X. So next slide. So you've probably heard of Jenkins already, or you probably wouldn't be on this webinar. Jenkins is the standard CI/CD tool that pretty much every enterprise uses. Pretty much every company I've talked to in the last few years has Jenkins somewhere. It's usually the strategic CI/CD tool in most companies. Pretty much everyone has a Jenkins somewhere, right? It started nearly 15 years ago, and it's been growing hugely ever since. So we have lots and lots of Jenkins. So Jenkins has been a massive success in CI and CD. Lots and lots of people use Jenkins and rely on Jenkins for their CI and CD. However, Jenkins was designed and architected 15 years ago when the world was very different. Before clouds, before containers, before cloud native was a thing. So it was built in the old Java application server days. So Jenkins has a number of issues today. So next slide. What are the challenges of using Jenkins today? Mostly it comes down to the traditional Jenkins architecture that was designed 10, 15 years ago. So Jenkins server is a traditional Java application server. It's a single point of failure. So Jenkins server is a single Java virtual machine. So if that Java server dies, it's not highly available. So your team basically can't do any CI or CD if the Jenkins server goes down. So the Jenkins server is a single point of failure, which means the Jenkins server becomes kind of like a pet and not cattle. So you have to kind of keep those servers up and running and polish them and tidy them and spring clean them and make sure they're good to go. Jenkins servers can easily run out of disk space. Whenever Jenkins server runs out of disk space, the Jenkins server tends to kind of fall over. So you might have to spend a bit of time monitoring and managing those Jenkins servers and garbage collecting the disks to make sure they kind of keep running. Installing plugins is one of the great things of Jenkins. There's like 1,500 plugins. You can add plugins for all kinds of different things. One of the challenges, though, is as you add and remove all kinds of different plugins, you can find that there's some plugins don't work with other plugins. Jenkins can become kind of brittle. So changing your Jenkins server can lead to downtime, which then leads to your team not being able to do CI and CD. Some folks who use GitHub often find the multi-branch plugin, which is very common to scan for pull requests and scan for feature branches. That can sometimes be overzealous in how many GitHub API calls it makes. So you can kind of hit API rate limiting. We certainly have hit that on the Jenkins X project in the past. And the Jenkins server itself is quite a large JVM. It's usually kind of 2 to 4 gigabytes of RAM. Now, if you're only running one of these, it might not be too much of a big deal. Lots of our customers have, 100, 1,000 teams. 100 or 1,000 of these VMs, JVMs running all the time can be quite a costly cloud bill. Developers really should only work around 40 hours a week. So if your team are co-located in one time zone, that's an awful lot of time every week that a Jenkins server isn't actually used. So keeping this fairly large JVM around all the time, just in case you might need a build, in a cloud world is quite expensive. So the architecture of having this single point of failure running all of the time, just in case you need a build, can be kind of expensive. Finally, depending on your pipeline and which plugins you use and how you write your pipelines, because a lot of the pipelines run in the Jenkins master, it's actually quite easy to crash the Jenkins master or make it hit out of memory errors. So you can get a brittle master depending on how you write your pipelines. So this whole slide lists a whole number of issues with the Jenkins master architecture, which I think we can do better, and we'll describe in a few more slides how we do better. So next slide. So what if we could reduce your cloud bills by only running Jenkins pipelines when the build is actually running? So there's no Jenkins master running until you need the Jenkins master to run the pipeline. So in other words, what happens if the Jenkins server became truly ephemeral? So it's properly serverless and comes into existence only when you need to do a build and then goes away again. Also, what if this build is completely isolated from all other builds? So one bad pipeline can't break other bad pipelines. So one developer experimenting with a pipeline cannot interfere in any way with any other pipeline because they're all completely separate containers running in isolation. What if we use CI and CD to validate, test, and roll out changes to Jenkins itself and Jenkins plugins, meaning that your production workloads are all completely isolated from any changes until you've tested those changes work and then promoted those changes into production? What happens if Jenkins was based on a highly available cloud-native webhook handler, so there was no single point of failure, so you never miss a webhook, so your team is always as quick and as productive as you can possibly be? What happens if Jenkins was completely scalable linearly, so that you're never blocked on how many builds are in your build queue, that if ever you need a build, providing you have enough capacity in your quota on your cloud, you can just do a build in parallel? What happens if we avoided GitHub scans, so that it doesn't matter how many pipelines you have and how many repositories, we don't hit those API limits in GitHub? And finally, what happens if we use Git to store every piece of configuration data? So even if you lost your entire cluster, you can just recreate everything from scratch pretty quickly. So let me walk through our solution to all these what ifs. But the quick answer is we have a solution for all of these things. So let me walk through what that solution looks like. So next slide. So firstly, before we go into the details of how all this thing works, I want to step back a little bit and describe a little bit about the changes that have happened in the last kind of 5 years. So when Jenkins was created, the ideal technology at the time was JVMs, Java Virtual Machines. Since then, a whole raft of changes have happened in the software industry. The first is this huge move to the cloud, whether that's public cloud, private cloud, hybrid cloud. The cloud doesn't really mean it has to be public anymore, right? There's Amazon, Google, and Microsoft are all supporting on-premise clouds. Various vendors like IBM and Oracle now support on-premise clouds and Pivotal. So now the cloud generally means a place of elastic infrastructure, network, compute, storage, which is elastic and managed by a vendor. So you don't have to manage horizontal infrastructure anymore. So the move to the cloud is a huge change, and pretty much every workload is moving to the cloud. Now you might say, we can't move to the cloud because it needs to be on-premise. In many ways now the cloud is on-premise or public or private or hybrid, right? You can run OpenShift or Pivotal on-premise, you can run Kubernetes on-premise, or you can use Amazon, Microsoft, or Google's on-premise cloud solutions. Ideally, we want to all use more of the public cloud because then it's completely elastic and we don't have any data centers to manage. So I think the public cloud is in many of our futures. Most of us will be moving most workloads to the public cloud, and the public cloud vendors are getting ever more capable and powerful at dealing with different regulatory issues or location issues. So I see most of us moving to the public cloud, but even if you can't move to the public cloud, you'll be using the private cloud or hybrid clouds and cloud bursting. In addition to this move to the public cloud, there's a huge move away from virtual machines towards containers. And why are containers so important? Two things. Mostly it's cost. Containers are about 20% cheaper than VMs. Why? Because with containers, we just run the software we wish to run. With VMs, we have to package up our application with a copy of Linux and the entire operating system. So we end up running lots and lots of copies of Linux on the same physical machine. With containers, we save that overhead and we basically get free hardware. So cloud and containers is our main future. So we're all going through this big digital transformation to go faster, to have better CI, CD and acceleration, and to modernize our infrastructure to use more cloud and more containers. Next slide. So Kubernetes is purely an implementation detail, but Kubernetes is now the canonical way of using the cloud and containers in a way that lets us run and manage software at scale and let Kubernetes deal with orchestration. So Kubernetes lets us run programs and manage them and operate them at scale automatically through software. So it's a way of running software like Google has done for the last kind of decade or so. So Kubernetes gives us loads of benefits around automating things like network and persistence and service discovery. It automates running upgrades of software. It makes things highly available so that if a process dies, it will be automatically detected and restarted for you. If you lose a whole machine or data center, it will completely scale over those workloads to another data center or another bunch of machines in a rack. So it's a way of running software, any software, elastically. It works with all kinds of software as well. So Kubernetes works not just in the traditional 12-factor applications that are kind of stateless, simple stateless microservices. Kubernetes works for databases, for message queues, for things which are deeply sharded, or any kind of application at all, really. So Kubernetes is really the platform on which we should all be building distributed applications these days. Next slide. Kubernetes helps in many different ways. One of the biggest things, and the thing I'm the most excited about, is Kubernetes finally gives us a cloud abstraction layer that isn't a leaky abstraction. So basically, Kubernetes lets us standardize on packaging software in a single Docker image and a single set of YAML or JSON metadata so that we can literally take that distributed application and run it reliably on any cloud infrastructure. So whether that's Google, Microsoft, Amazon, whether that's DigitalOcean, whether that's IBM or Oracle clouds, whether that's Pivotal, it really doesn't matter what kind of cloud provider you're using. Your application will work on all these different Kubernetes platforms, which is a huge big deal. Right? Before Kubernetes came along, the cloud was a whole mess of proprietary APIs. So it was kind of a nightmare trying to build an application that worked in a multi-cloud way. Increasingly, many businesses are now relying on having a multi-cloud strategy. Talk to most investment banks, for example, these days, and their regulator is enforcing in many markets that they must support multiple cloud providers. It just makes good economic and business sense, right? If there's a massive outage and the whole of Amazon were to go down, well, at least you could use Google or Azure and vice versa. Now, increasingly, a lot of people tend to pick one cloud provider, but being able to at least switch, if you really have to, gives you a massive economic benefit and avoids kind of lock-in. So multi-cloud is very, very important these days. But being able to just make your application portable and being able to learn a technology and have a transferable skill from company to company is really, really important. It reminds me a little bit of the whole Java became a really cool language to learn and use because it didn't really matter what operating system the company you worked at used. You could move your Java skills from company to company. And there's a parallel here with Kubernetes. If you learn how to build distributed applications with Kubernetes on, say, Amazon, and then you change jobs to a different company, that company might have picked Azure or they might have picked Google. Your skills and your applications and your tools are transferable. Kubernetes is multi-language, so it means you can literally use the best tool for the job. You could use Java, you could use Kotlin or Groovy, you could use Go, you could use Node, you can use any programming language you like, really, so long as it compiles down and works on a Linux container. So if it runs on Linux, you're good to go. For me, the most exciting part of Kubernetes, though, is there's now a really rich, diverse, and exciting open source community around Kubernetes, focusing on all aspects of the infrastructure problem, whether it's Prometheus to focus on managing software and operating it and doing fine-grained alerts and adding lots of deep metrics into every piece of software and libraries and tools there are, to things like Helm for package management and packaging applications up and making them easy to install and upgrade, to things like Istio, providing a canonical service mesh that lets us do automatic load balancing and fine-grained network policies and automatic retries and wiretaps and all those kind of things. So there's a whole raft of amazing open source solutions coming out that are all based on this new standard Kubernetes. Okay, next slide. By the way, a quick question I just saw fly by. The 20% cost saving comes from an IBM paper. If you Google the IBM paper for virtual machines versus containers, they did a massive study that compared the same software running in virtual machines versus containers, and they found 20% was the average cost saving of using containers versus VMs. Anyways, let me talk about Jenkins X now. So we started Jenkins X about a year ago, and the main focus of Jenkins X was we saw the rise of the cloud. We saw the rise of containers, that most workloads are going to gravitate towards the cloud and towards containers over time because of the economics, really, of moving to an elastic cloud platform and then moving to containers to save money on infrastructure. So what we wanted to do was help developers move to Kubernetes. So we wanted a way of automating CI and CD for Kubernetes on the cloud. We realized that not that many developers know what containers are and how to do containers well, and similarly how to use the cloud well, and finally what Kubernetes is and how to use Kubernetes. So the main focus and goal of Jenkins X, at least initially, was how do we make it easy to move developers from building Java or Node or Go or whatever applications today to doing that well on Kubernetes in the cloud. So Jenkins X's focus initially was assuming this new cloud Kubernetes future, how do we make it easy for developers to move to Kubernetes and then automate all of their CI and CD for them so they don't have to worry about CI and CD? So Jenkins X assumes Kubernetes, just like Jenkins originally assumed a JVM. Jenkins X assumes a Kubernetes cluster. So it assumes Kubernetes is there, so we can easily spin up lots of distributed processes on top of Kubernetes, and we assume Kubernetes is going to orchestrate all of these. If you kind of squint, you can think of Kubernetes as a new kind of application server, only it's not a single machine. It's a cluster of lots of different machines, and you're treating the entire cluster as if it's a single logical machine. So it's almost like turning a collection of Linux machines into kind of like a mainframe, but a mainframe in a good way. I mean, in something you could submit jobs to and it just works. So Jenkins X is focused on using Kubernetes well and automating CI and CD for Kubernetes. One of the kind of side goals of Jenkins X is to try and make Jenkins X more cloud native, or to slowly re-architect and bend and improve Jenkins so that it works in a more cloud native way, as in it uses the cloud well, okay, which I'll talk about in a moment. One other, and this is more of an implementation detail, but another thing Jenkins X does, Kubernetes has a thing called Kubernetes resources. So if you want to run a container in Kubernetes, there's a resource called a pod, which is one or more containers. So there's all these different resources in Kubernetes, which is a declarative metadata way where you can describe what you want to happen. I would like you to run a pod, please, and then Kubernetes makes that happen. So it's constantly got this feedback loop, looking at the declarative metadata and making it real. What Jenkins X has done is extend the Kubernetes platform with DevOps and CI and CD resources. So for example, you can define at a per team basis in Jenkins X environments like development, testing, staging, and production. You can expose pipeline activities, or in other words, visualize pipelines running via Kubernetes resources. We have a Kubernetes resource to describe a release, which contains metadata like what's the release version, what's the Git repository, what's the Git SHA, what issues were fixed in a particular release, what commits were made, who did what commit, where's the build log that did the release, and so on and so forth. So Jenkins X adds a whole bunch of custom resources to extend Kubernetes. So that's Jenkins X's main goal, automate CI and CD for Kubernetes and try and make Jenkins ever more cloud native. Next slide. Now, Jenkins X's initial goal is automate CI and CD for Kubernetes. So what does that mean? So it means when you import your code into Jenkins X, it sets up the CI and CD pipelines. So when you merge a commit to the master branch or the release branch of your repository for your application, Jenkins X automatically generates a new version number and then creates and builds and releases all of the artifacts for your project. So if you've got a Java project, that will be jars. If you've got a Node project, it will be NPM modules. If you've got C, C++, or Go, or something like that, it will be binaries, and it will distribute the binaries. Now, because it's Kubernetes aware, it then generates Docker images for those artifacts and tags them with a version number. It then generates Helm charts and again tags them with the version number. So it essentially releases the new versioned artifacts for your code, which is cool. But the new thing we do is we also then promote those artifacts through your environments using something called GitOps. So we will move a specific version of your application from development to testing to staging to production. And under the covers, we use a Git repository for each environment. So every environment has the configuration in metadata of which versions of which applications it runs in that environment and which configuration for that environment. So a particular application might run in production. If you wish to upgrade a new version of that application in production, we'll automatically generate a pull request or a commit that will request a change of the version of the application. You'll see all of this in a demo later today. So that's the Kubernetes workloads. Now, what we wanted to do was make Jenkins X usable for other kinds of workloads. So whether you're using a different way of performing continuous delivery, or possibly you're not even using continuous delivery at all. Maybe you just want to do releases of jars and libraries and binaries. So today we have two pluggable workloads. One is the Kubernetes workloads, and the other one is the universal workloads, which essentially do the traditional CI stuff. When you merge the master, we make a new release, we distribute the artifacts and binaries, and that's it. We then leave the delivery part to other folks or other pipelines. The intention is for us to also add more build packs to support different kinds of platforms, like, for example, Cloud Foundry, possibly Lambda and Fargate, maybe serverless or something like that. So over time, we're hoping the community builds out more and more build packs for other kinds of platforms. But today we have these two kind of pluggable workloads. Okay, next slide. So the next thing on the list, so we have the pluggable workloads. The next thing we wanted to do was support serverless Jenkins. So this means you get a choice with Jenkins X. Each team either gets their own traditional Jenkins server, the Jenkins server you know and love from the last 15 years, that JVM that's always running, that controls and orchestrates all the pipelines. So you either use a static Jenkins master, as we call it, or you can use serverless Jenkins. And essentially, serverless Jenkins just means there is no Jenkins master anymore. There's start a Jenkins container just for that build pipeline. Then as soon as the pipeline is complete, we terminate the container. So this is a radically different implementation detail for how to do pipelines. You either have a static Jenkins master that orchestrates all the pipelines itself, or you have serverless, which there is no master. And essentially, we're using Kubernetes to orchestrate the builds rather than the Jenkins master. And if you remember the slide a few slides ago, like what if, like the big if about the serverless is there's no Jenkins master, so there's no cost of running for every one of your teams, 2 to 4 gigabyte JVM that runs all the time. You literally just run a build container for the duration of each build, and then it goes away again. You also get the benefit that each build is truly separate from each other. The builds can't conflict in any way with each other. Each build is using its own local file system and its own temporary local transient file. So you don't get issues of builds conflicting with each other. If you write one really bad pipeline that uses up way too much memory and it kind of core dumps as it runs out of memory, it's not going to affect any of the build pods. So it means everything's rock solid, everything's completely elastic, and there's literally nothing to manage. With static masters, you kind of have to manage those like pets. You have to feed them and polish them and groom them and keep tidying up after them. With Serverless Jenkins, they're cattle now. So you don't literally have to even touch them. It all just kind of works. Okay. So Serverless Jenkins means essentially there's no Jenkins server running anymore. And we spin up dynamically build pods when a webhook comes in, and then we trigger the necessary Kubernetes infrastructure we need on demand. So that's the basic idea behind Jenkins X. So I'm now going to pass over to James Rawlings, who's going to walk through the detailed implementation behind the curtain of how Serverless Jenkins works. Over to you, James.
Thanks, James. Okay, so hello, welcome everyone. Yeah, I'm going to dive into a little bit more detail here, and then we're going to do a bit of a live demo as well. So James mentioned about some of the exciting and the innovation happening in the Kubernetes ecosystem. One of the first ones to talk about here is a project called Prow, which we're very, very excited about. Prow is used on every single Kubernetes repository on GitHub. So this is 140 repos today. It's also used by other open source projects such as Istio and Jetstack. What does it do? Well, it's actually an event-based solution. It uses custom resource definitions that James mentioned and described about before. It allows us to have an event-based architecture to handling webhook events from Git providers. It is a number of microservices. I probably won't go through all of these here, but there's a URL at the bottom where you can go and get some more information. But the idea is you have separate microservices that can be scaled up independently, such as Hook, which receives webhooks, so you can actually have a highly available webhook endpoint. We've got other components that actually run as well to kind of to do auto merging or make pull requests, and there's a number of different plugins that you can actually extend with Prow as well, which we're going to see these in the demo. It's a very exciting project, and it really helps us enable, give us lots of control over our CI and CD pipelines. The second project I wanted to talk about is KNativeBuild. Again, from the Kubernetes ecosystem, there is an effort around having a consistent way to be able to trigger builds or have builds run on Kubernetes. This is obviously very interesting from a Jenkins point of view. Again, using custom resource definitions, so extending Kubernetes in the way it's intended to be extended. You can actually string together multiple steps and run them serially in a Knative build. It uses something called init containers, which means it's very easy to actually run these serially. That's probably a bit low level. And it also means you can actually share state between these different steps. So again, at the bottom there's a link to the Knative, and we're also working with the Knative pipeline effort as well. A couple more things. There's something called a KNativeBuild Template. Now, for anybody that's used Jenkins on Kubernetes, they've probably used the Kubernetes plugin. This is service well. It actually helps orchestrate builds on Kubernetes, and you define a pod template. This is a similar kind of concept. On the right-hand side, there's an example of a bit of YAML, and this is a Kubernetes resource. This is a build template. So this is a custom resource, a definition as well. This is a custom resource, sorry. And in here is describing what image to actually run for our build. So you can see on line 25 there, it's actually running Jenkins IO, Jenkins Maven image. So this is actual Jenkins, an ephemeral Jenkins that gets started and run for the duration for this build. We've also got some other environment variables that we're actually passing in as well, and some resource limits. This is actually a typical Kubernetes pod specification. So for anybody that's used Kubernetes, this is very familiar. But it's okay that we don't have to remember all of this. We're actually going to generate all of this on Jenkins X. This is a bit of a busy diagram, and maybe it's a bit small for this, but I really just wanted to kind of describe this event-based nature that we're now looking at, where we react to webhook events from, say, GitHub, and we would actually send events over to this highly available webhook event handler. This webhook event handler will create a Prow job. This is a custom resource in Kubernetes. Now there are other controllers that are actually running, watching, looking for these for these resources to be created. When one is created by when a proud job is created, we have something else called a proud build controller, which then reacts and in turn creates a KNativeBuild resource. Again, this is this event-based architecture that we're now looking at. We have a KNativeBuild controller, which reacts to the build being created, the build object, and then spins up a pod with our serverless Jenkins inside to perform the build. We then have other microservices that is sending reporting statuses back to GitHub as well. So just to swing back a level to Jenkins, some of the great work in the Jenkins community, they've been working on something called the Custom War Packager. This is a fantastic tool. What they actually enables us to do is build custom Jenkins images, and we can define using YAML a list of plugins, a custom set of plugins, and it will actually build us our custom images. So, but this gets checked into source control, which means we can actually manage our plugins using CI and CD. So there's no more changing on the fly, installing plugins on demand through UI. We're now using configurations code and GitOps for everything. So we want to ensure that we use CI/CD when we make an upgrade of a plugin or we add a new plugin. So we can actually prove that change is going to work before we roll out. What are the other interesting things is, typically in Docker containers, the Jenkins JVM tends to take a while to start up. We saw on the Jenkins X project in the early days, it was taking up to 2 minutes to actually start the JVM. Now, in the custom war packager, I believe it's because they've extracted plugins initially, but the JVM is starting up in sub 5 seconds. So we've got nice fast builds being started very, very quickly. Okay. There's also another project called the Jenkins File Runner. Again, a link's at the bottom there. This allows us to spin up to run our Jenkins server and execute as a pipeline execution engine. So that, again, this is in a headless approach, so there is no Jenkins server master running statically all the time. This is just a one-shot Jenkins run for the duration of the build and thrown away afterwards. That's where we get all the benefits that James Strachan was mentioning earlier on. Okay, I'm going to drop into a demo now. Let me just move this across. I'm going to hopefully show this in action. We've got, I've got a Jenkins X installation already running on a Kubernetes cluster on Google Container Engine. If the CLI to interact with Kubernetes is called kubectl or kubectl, kubectl get nodes. So you can see that we've got a 3-node cluster that's actually running on Google Container Engine. I've mentioned that we've installed Jenkins X as well. The user interface for Jenkins X is actually, again, through a CLI. We have a CLI binary called JX. This allows us to perform a number of operations, like creating clusters or managing or investigating the cluster, builds, triggering builds, even creating quick starts as well. There's a lot of documentation on the website. I'd encourage anyone to have a look. But it means we've got a lot of control at our fingertips, which developers love. So if I just check what we've actually, as we've installed Jenkins X, we've actually installed it with created some default environments. These are customizable, but we've got we see here a staging environment and a production environment. Now, over here, we've actually got URLs because in Jenkins X, we leverage something called GitOps, which means that any change that needs to go into that staging environment has to go through via a Git repository. It needs to be approved and then merged, and that will then trigger the deployment into our staging environment. We use something called Helm, which is a package manager for Kubernetes. And this is, but we could use just vanilla Kubernetes YAML if we wanted to. But we can see that this is just a way that we can package up our applications for our environment and then deploy them. So we've got some default environments created. We're going to create a quick start. So JX create quick start. We can also import applications as well using different languages. So if you have an existing Golang or Node.js or Java application, we can actually import this as well and configure and set up everything for you. But let's start with a JX create quick start. We've got some pretty basic quick starts to go for. They're very simple, and these are building up and growing all the time. But just for the demo purposes, we're going to use the Golang HTTP quick start because it's nice and fast. So we're going to create a quick start. Let's give it a name, webinar demo 1. This is going to go and create us a Git repository, and it's going to use my Git credentials, my GitHub credentials, to then go and create that repository in GitHub. So use my name. We're going to initialize with Git, yes. But once we take that quick start, we're actually going to add a build pack. This is some build packs James mentioned before. So we can enrich this repository with ways to actually build and package and deploy this application. Oh, sorry, and run this application. So I'm going to go over here and create this in a separate shared Git organization. Hit enter. And that's going to push that, create the repository on GitHub and push the code up. So we can go and have a little look at this now. It's down here. So we can see here, we've just created this 17 seconds ago. This is our webinar demo 1. We've got a very simple Golang example, which is just going to show a nice title screen when we go and look at this application when it's get built and deployed. You can see here that we've got a Jenkins file. This is the pipeline that's running that will get triggered. We've also got a Docker file here as well, and we've got some Helm charts. This is the packaging for this application to be able to run on Kubernetes. So we've generated all of this for you. We don't hide anything either. This is all in the Git repository. So you can go and then, if you're not familiar with these concepts, you can actually go and then start tinkering and playing and extending this, but you've got protection of the automatic CI/CD that we've just set up by Jenkins X. You can see here that some of these deployment YAMLs can be quite complex. So when getting started with Kubernetes and onboarding with Kubernetes, this is very easy for developers to get going. So what we should, if I just switch gears slightly, because I've created this application, I should be able to go into it. Webinar demo 1. Here we go. We've got the code here. I should actually, if I just do JX get build logs, we can see here we've actually been build was automatically triggered. This was running our pipeline. Probably ignore the initial error there, but that's just a warning. We can see that this is actually running our Jenkins file. So this is going through and actually building the image. It's done a release of the image. It's built the image and it's pushed it to a registry. Then it's packaged up that application and added it to our chart repository that we can actually then go and deploy and promote this into a staging environment automatically. So if I come out of this, JX get apps, well, nothing actually deployed yet, so we can actually go and have a look whilst that's running. Using kubectl, we can actually see what's actually running, what the builds that are actually running for this application. Now, you may be able to see, if anybody's got a keen eye, we're actually not running our static Jenkins here at all. So we can actually go and geek out a little bit and have a look at kubectl get pod. And we're going to have a look at this resource and actually have a closer look to see what's actually running in this pod on Kubernetes. This is where we're actually running our Knative build pod. So for here, initially, what Knative has done is allowed us to be able to clone this repository, this GitHub repository. It's also mounted some credentials in as well. So we have the, if we had a private repository, for example. Now these are all running as init containers as separate individual containers on Kubernetes serially. So first it did the credential initializer and then checked out, cloned the source code for our Git repository from GitHub. Now the next interesting one here, this is our image. This is our serverless Jenkins that's been triggered and running for the duration of that build. If you have a little look again, kubectl pods, that build there, oops, which was 3 minutes ago, has now been completed. So that pod is actually now not running anymore. We've performed the build, we've run the build, and we've thrown it away afterwards. We've collected the logs, and we've collected the artifacts out of this pipeline as well. So we've got no reason for it to stick around anymore. And okay, so let's have a look at JX get apps. We should have, there we go, we've got our JX webinar demo. It's actually running in our staging environment. So we should be able to go and see this. There we go. Very, very simple, quick start. Now what's interesting, and this is where it comes from a developer experience, let's switch gears and try and do something a little bit more meaningful. So let's check out onto a different branch. Let's make a change. Let's just use Vi for simplicity. Change our main.go and edit some change. Hello. Save that. I'm going to commit this change and I'm going to push it up to a new branch called work in progress. Let's say -m. Right, git push. If I push to my work in progress branch, we can see, we should be able to see this now. Work in progress. We're now going to be able to make a pull request onto our master branch. Jenkins X, when we created this quick start or we import applications, we automatically set up and configure all of the CI and CD for you. Again, it's customizable, but we've set up webhooks and everything on the Git repository. So when I create a pull request, we're going to want to, it will be triggering our CI build automatically. So you can see here, there's a serverless Jenkins build that's running, it's being triggered. Again, no static Jenkins is running. We're just running a serverless Jenkins for the duration of this build. It's kubectl get pods that we can see is running here. Now, you may have noticed some more interaction. And this is, again, one of the huge benefits of Prow. We can see that we've got some Prow plugins that have been enabled. So we've got labels that have been added. We've got a message saying this change has not been approved. What this means is that we can actually start building up a conversation using chat ups on this pull request to trigger different behaviors that go over to Prow. Again, this isn't just a consistent way. What we can actually do is customize and adapt Prow to actually trigger different behaviors. For example, we have some nice plugins that we have. We can make a comment of meow, and we should get some response from a Prow plugin. There we go. Always risky in a live demo, making sure that it's a suitable image returned. But that kind of gives you just an example of what the triggering, the chat-based interaction we can actually have in these pipelines. Any second now, the serverless Jenkins build should finish. Give me a second now. Whilst that's going on, what I might do is actually show you the CloudBees commercial offering UI that we're working on as well. Because as you can imagine, because we are using serverless Jenkins, we're not actually having, we don't have any UI, any traditional classic UI that folks will be familiar with. We have, CloudBees have we're working on this graphical user interface here that allows us to be able to visualize our pipelines, get our build logs, and also see in our environments actually our applications being deployed. So you can see I've got this is where we've got some examples. That's our webinar demo that's running in our staging environment. So if I go back, that's not running yet. At some point that's going to finish the build and actually comment on this pull request, and it will automatically create a preview environment. Whilst that's running, just want to see if we can actually see the webinar demo 1. So this is the initial master build that we ran. So there was the logs that we've got. So we've managed to get the logs out of the serverless Jenkins pod. And this is the pipeline that's actually been run as well. So again, we're using custom resource definitions in Jenkins X to be able to persist this information with Kubernetes. But we don't need that serverless Jenkins image hanging around anymore. I'm probably going to switch back. I've just noticed the time. So hopefully that kind of gives a bit of an idea of what we're actually doing, some of the benefits and some of the innovation happening around the Kubernetes ecosystem. As James mentioned, this is a cloud native journey ourselves that we're taking. We know others are going to be taking on their own, embarking on their own cloud native journey. And this is where we wanted to share with our latest innovations around Jenkins and Jenkins X. James, did you want to add anything extra? I think maybe we go to some questions or something.
No, I think that was all awesome. Well done. I think should we go for questions, or did you want to do anything else? Did you want to do the preview environment?
Well, yeah, actually, the preview environment's just popped up. So let me just in time, you can see that we've actually got a preview environment now. We can see that's the text that we added in. And then you actually then just comment back. Again, you have different rules, but we can actually approve this. All looks good to me. You can have a different number of people approving, and then that's going to get auto-merged, built, released, deployed out into our staging environment. Using the GUI as well in our environment, we can actually perform promotions into our production environment as well. So that's, for example, let's just trigger that whilst we answer the questions. We'll see that go as well. Yeah, sorry,
awesome.
James.
So the preview environments get generated on pull requests, and then people get to test out the code running in Kubernetes before you merge to master, that's really awesome.
Yeah.
Okay, let's do some questions. We've got lots and lots of questions, so let's crack on. We've got about 15 minutes to go through these questions.
Awesome.
So the first question, which we should probably make more clear whenever we talk about Jenkins X, can you use other source control systems like Bitbucket? We support Bitbucket Cloud, Bitbucket Server, GitLab, and we're working on more providers like Gerrit and Gitea. So our aim is to support lots of different Git providers. However, for serverless Jenkins, static master Jenkins, we support lots and lots of Git providers. For serverless Jenkins, today, GitHub is the only supported offering. We're working hard to extend Proud to support lots of different Git providers. So if you want serverless, unfortunately, it's GitHub only today, but we're working really hard on making that work with GitHub Enterprise and Bitbucket in that order. Another great question, I posted a link on the chat with the more detailed answer, but another question was, does Helm need Tiller on Kubernetes? So Helm is the package manager we're using by default to package Jenkins X itself and all of the applications we deploy in all the different environments. And Helm version 2 requires a server-side component called Tiller, which is not awesome, and we recommend you don't use it. We have a blog that shows how to use Jenkins X without Tiller using version 2 of Helm. Version 3 of Helm, which is coming out hopefully at some point next year, doesn't have Tiller anymore. So Tiller is a thing that's going away, and Jenkins X comes with a way that can avoid Tiller on version 2 of Helm as well. Another question is, Jenkins X hosted as well as Kubernetes? Basically, Jenkins X installs itself into Kubernetes. So long as you have a Kubernetes cluster, you can install Jenkins X inside using JX install. If you don't have a Kubernetes, there's a command line called JX install. If you don't have a Kubernetes cluster, there's a command called JX create cluster, which will spin up a Kubernetes cluster for you and put Jenkins X on top. So either way, all you really need is a Kubernetes cluster. Jenkins X can install itself on top of that, and you're good to go. Next question, will shared pipeline libraries still work with serverless Jenkins? Yes, they do work. We can't guarantee that every single pipeline will work. There could be some pipelines that don't work. We're obviously going to try and make as many things work in serverless Jenkins as possible because we see it as the long-term strategic future, really, of the Jenkins ecosystem. We want everything to be serverless and highly available and elastic and so forth. So we want everything, or most things, that we can get to work in serverless Jenkins. But it's definitely well worth testing. Does your pipeline work in serverless versus non-serverless? We're hoping to build a tool at some point that automatically migrates pipelines to serverless. So it one by one goes through all your pipelines and moves them. And if they work in serverless, it leaves them there and then removes the old static master version of the pipeline. to ease migration. But feel free to just migrate manually for now until we get there. Lots more questions. Go for it. Yeah, go for it, James.
I'll add something in around the shared pipeline libraries, actually, because one of the previous projects we worked on, we actually used the shared pipeline library quite a lot. And we have Jenkins X ourselves. We have actually moved away from it slightly. It's just really worth mentioning. We're using the declarative approach. This is also going to help us go future-proof going forward with some of the other initiatives around Kubernetes, that around Knative pipeline that we're working with from CloudBees. So that's really wanted to mention that. There was quite a few benefits from doing this approach as well, around maintaining and testing as well. But yeah.
Just to be clear what James just meant then, in case it wasn't clear, instead of using shared pipeline libraries, an alternative is to use shared Docker images, which have tools in them that do one thing well. We found that having reusable command line tools tends to be much easier for developers to use and work with and test, and then package those up as a Docker image and then share those from across pipelines, which just seems easier to get shared functionality that's easy to test. So we've internally moved away from shared pipeline libraries, but if you have them, it's fine, they will still work. But I think long-term, I think Docker images seem to be an easier way of sharing reusable functionality and so forth. Loads more questions, so I'll crack on through more. Is it possible for users to change custom resource definitions based on the requirement of a project? Yes, absolutely. Custom resource definitions can be changed and edited by users. All resources in Kubernetes, whether they're the baked-in ones like service and pod, or custom resources like the Jenkins X ones, environment, pipeline activity, and project and resource and so forth, release and so forth. All of those use role-based access control, so you can define in which namespace, which users can read them, write them, watch them, get them, delete them, update them, and so forth. So absolutely, users can change those. From the JX command line in Jenkins X, you can do JX get env, as you saw James do. You can also do JX create env and JX update env, or you can use kubectl to edit environments and create environments, and similarly with any of the resources. So yes, you can absolutely change those. We want you to be able to define and customize each team to use whichever kind of Jenkins server you wish to use. Do you want to use serverless or static? Which build packs? Those are configurable on a per team basis, and all of that is stored in custom resources. So which build packs, which environments you wish to use, which repositories and so forth, that's all CRDs. How does Jenkins X manage concurrency and queue for resources? That's a really good question. So basically, Jenkins X delegates, when you're not using a static master, Jenkins X delegates to Kubernetes to orchestrate resources. So what that means is, based on your quota per team, different teams can have different quotas. So based on your quota per team, if you have enough quota, in other words, enough capacity in your cluster, builds will be instantly started and will run instantly as soon as they're required. There's no queue per se. However, if your cluster or your namespace is out of resources, Kubernetes queues up those resources and they're started in a kind of priority order. So if you like, there's kind of a queue in a Jenkins sense, but normally there isn't a queue because you've usually got enough capacity so that all the builds can start instantly, because it's based on how much CPU and memory and disk you have in your cluster. From a concurrency perspective, the containers are completely separate from each other. There is no contention or locking or semaphores, so there is no concurrency issues in that sense. I guess, strictly speaking, there's a small amount of concurrency, and that's allocating a build number. So we do that inside Jenkins X to allocate the build number, but which we're actually using custom resources to do the locking or optimistic locking. What is the relationship between Jenkins X and Knative? James kind of answered that, but James Rawlings answered that. But the basic idea is Jenkins X uses KNativeBuild to implement serverless Jenkins. So it's kind of an implementation detail under the covers. Jenkins X actually supports vanilla KNativeBuild as well, if ever you choose to do any pipelines in that way. It's fairly low level, but if you kind of really wanted to go that way, it's fine. We actually surface all pipelines, whether they're Jenkins pipelines in static masters, whether they're serverless Jenkins, or whether they're vanilla Knative builds. They all appear in our console the same, in the CLI the same, as custom resources the same, in our IDE plugins the same. So we have a unified way of viewing all of these builds, whether they're KNativeBuild or serverless Jenkins pipelines, or whether they're static Jenkins master pipelines. Over to you, James.
Yeah, just on that, actually, exactly what, as you were just describing on the screen, I actually went to the environment deployment, which is, again, it's a pipeline, but this is just using vanilla Knative build steps. And you can see the visualization that James just described then. It's all through in the UI in the same approach. So this isn't actually using a serverless Jenkins. We have pluggable pipeline engines that serve the right purpose for the job.
And you could view those with kubectl get pipeline activities as well. So you could use the command line to view those. You could use, we have an IntelliJ plugin, we have a VS Code plugin. So there's various different ways you can grab that data. You could write your own tools to watch these different pipelines run in real time and respond to them if you kind of wish and so on. Okay, while James is typing, I'll keep going because there's loads more questions. So is Jenkins X always running against serverless Jenkins, or can it also work against the pet server? So Jenkins X supports each team in Jenkins X can have either a static master or a serverless Jenkins. So you can have many teams on one Kubernetes cluster, and one team can use serverless and one team can use static masters, and you can mix and match. So we support both at the same time in the same cluster. Another question is, how does the workspace behave? Does it go away again after every build? Yes, it does. So the idea is each serverless Jenkins build, the workspace goes away after each build. If you ever wish for that to be long-term persistent, then your pipeline needs to rsync to some remote repository or use some kind of persistent store or S3 or whatever to deal with long-term storage. What we generally hope people use is, if you want to publish an artifact, use cloud storage, use a Docker registry, use Nexus Artifactory or something like that, or use a separate pod which has a persistent volume inside it that you can then send content to or sync with in some way. So you could have a separate pod you rsync to that's just basically a persistent volume if you wish. One other question, which I hope we answered, but I'll say it anyways. Does Jenkins X only deploy to Kubernetes? So Jenkins X itself requires Kubernetes to operate, but the builds which run inside Jenkins X can deploy to anything. You can use any Jenkins file that uses any technology to deploy anything anywhere. The only automated continuous delivery pipelines we have baked into Jenkins X are for Kubernetes deployments only today, but we're hoping the community helps us build support for things like Cloud Foundry, maybe using Ansible to deploy tarballs over SSH to a bunch of kind of legacy boxes, possibly VMs on EC2 if people aren't ready to move to containers yet, possibly serverless, Lambda and Cloud Functions and Fargate and stuff like that. So we hope to support delivery or continuous delivery to lots of different platforms, but our initial focus is very much containers and Kubernetes right now. I think we're almost out of questions. There's a few questions for articles which we've posted in the chat. We'll probably do a blog after this with a few more links to more articles. Any questions that I've missed, James?
I think, as you just mentioned, I think somebody's asking for more documentation to helping new development teams. So yeah, we've got some blogs out there already, but yes, absolutely, we'll be doing a series of blogs and getting started guides and videos as well to really help developers and teams get up and running with this.
Yeah, I think one of our biggest focuses right now is really helping folks adopt and understand this. So we do need much more work on the documentation and articles and videos and blogs and stuff. There is a lot of stuff at the Jenkins X website. If you go to the Jenkins X website and look at the demo section, there's quite a lot there. I'll post that in the chat as well. So there's quite a lot of videos and demos and stuff there, but we can almost do a better job and have more stuff. Okay, I think we're out of time, and I think we're just about out of questions, I think. So thank you very much for spending your time with us. I hope you try Jenkins X and serverless Jenkins on Jenkins X. Any feedback or questions after this webinar, if you go to the Jenkins X community site, we're all hanging out on Slack all the time. I'll just post that in the chat. So there's a whole bunch of us sat in Slack chat rooms all day. So if you've got any feedback or questions about Jenkins X or Serverless Jenkins, please pop into Slack, ask us anything you like, and we'll do our best to answer. So thank you very much for listening.
Thank you.
Thanks, everyone.